Welcome. Today we'll talk about chemical hazard communication. This training will help you understand the chemicals you work with, their dangers, and how to stay safe. Chemical hazard communication is about ensuring you're informed and protected when working with hazardous chemicals. You need to know what chemicals you're handling and the dangers they pose. It also includes knowing where to find more information, like safety data sheets and chemical labels. And most importantly, how to stay safe by using PPE and proper procedures. Here's what we'll cover today. Hazardous chemicals, what they are and the health risks they pose. How these chemicals can enter the body. How to read chemical labels and understand safety data sheets, or SDS. Finally, we'll cover protective measures against hazardous chemicals. A hazardous chemical is a substance that can harm your health. The level of harm on your body depends on the type of chemical and amount of exposure. The effects of hazardous chemicals on the body depend on 1. Route of entry. Chemicals can enter the body through inhalation, skin absorption, or ingestion. Each route poses different risks. 2. Chemical form. The form, solid, liquid, or gas affects how the chemical reaches and interacts with the body. 3. Exposure. Both the amount and duration of exposure matter. Even low doses can be harmful over time. 4. Toxicity level. Some chemicals are highly toxic in small doses, while others require more significant exposure to cause harm. The three main ways that hazardous chemical can enter your body include 1. Inhalation, breathing in vapors, dust, or fumes. It's the most common workplace exposure route and can quickly affect the lungs and bloodstream. 2. Absorption. Chemicals contact the skin or eyes and are absorbed into the body. 3. Ingestion, swallowing chemicals unintentionally, often from contaminated hands, food, or tools. Inhalation occurs when we breathe in airborne chemicals, such as dust, fumes, vapors, or gases. These can quickly reach the lungs and enter the bloodstream. It's a common workplace exposure route in environments without proper ventilation or respiratory protection. Absorption happens when chemicals come into contact with the skin or eyes and are soaked into the body. Some chemicals can absorb through your skin and affect internal systems, while others cause local damage like irritation, rashes, or even chemical burns. Ingestion refers to swallowing chemicals, often unintentionally. This can happen from contaminated hands, food, drinks, or even tools. Airborne chemicals can settle on food or drinks and be ingested. Good hygiene, like washing hands before eating or drinking, is key to preventing this route of exposure. Chemicals can be a solid like rock, metal, and dust. It can be a liquid like water. Finally, it can be a gas like propane or a vapor like ethanol vapors. Chemical solids in the form of dust powders can become airborne during tasks like grinding and welding. They can be inhaled when released in the air. They can also settle on food or drink and be ingested. Examples of reducing exposure include use of a dust mask, proper ventilation, and keeping food away from the work area. Liquids chemicals can cause skin problems through contact or be absorbed into the body. Some liquids can be absorbed through the skin. They can also evaporate into the air, forming vapors you might inhale. Gases and vapors can enter the body through inhalation, making them a serious respiratory hazard. Vapors are the gaseous form of liquids, like solvents, that evaporate into the air. Many common solvents, such as acetone, emit vapors that can affect your health even without direct contact. Proper ventilation and respiratory protection are key when working with hazardous gases and vapors. Chemical toxicity depends on the amount of chemical that enters the body, which is also referred to as the dose. A small dose might not harm you, but larger amounts can be dangerous. Beyond toxic effects, some chemicals are flammable, meaning they can easily ignite near heat, sparks, or open flames. Others are explosive, especially when pressurized or improperly mixed. Corrosive substances can eat away at skin, eyes, or metal surfaces, causing severe damage. Oxidizing agents can cause or intensify fires when combined with other materials. Information about chemicals comes from chemical label that gives a quick overview of a chemical, safety data sheet or SDS which provides detailed instructions. Every chemical product label must include 6 key elements. Let's go over them. 1. Product name. This tells you what the chemical is. 2. Signal word, danger or warning indicating how hazardous it is. 3. Hazard statement, a brief explanation of the dangers like causes skin burns. 4. Pictogram, a visual symbol showing the type of hazard. 5. Precautionary statement, steps to take for safe handling, like wear gloves. 6. Manufacturer details and contact information for more questions. Pictograms are designed to quickly show you the type of hazard. Let's break them down. Health hazard pictogram indicates chemicals that can cause serious and long-term health effects, such as carcinogenicity, respiratory sensitization, reproductive toxicity, or organ damage. Flammable pictogram represents chemicals that can easily catch fire. Examples of chemicals includes all fuels and many solvents like ethanol and acetone. Toxic pictogram with exclamation mark represents substances that may cause irritation, allergic skin reactions, drowsiness, or dizziness. It may also signal less severe toxic effects. Gas under pressure. Pictogram indicates gases under pressure, such as compressed, liquefied, or dissolved gases. They can pose explosion risks if heated or ruptured. Corrosive pictogram indicates chemicals that will cause skin burns or eye damage or lung damage if inhaled. Examples of corrosive chemicals are all acids and all caustics like sulfuric acid and sodium hydroxide. Explosive pictogram represents explosive or self-reactive substances that can detonate or undergo a rapid chemical reaction. An example of an explosive chemical is TNT, which is not common in most workplaces. Oxidizer pictogram indicates chemicals that increase the amount of oxygen in the air, therefore increasing the risk of fire. Examples include oxygen gas, ozone, and hydrogen peroxide. Aquatic toxicity. Pictogram represents substances that are harmful to aquatic life with long-lasting effects on water ecosystems. Acute toxicity. Pictogram indicates a chemical that is acutely toxic and can cause death or severe injury if swallowed, inhaled, or absorbed through the skin. Examples include mercury and chlorine gas. The chemical safety data sheet has 16 sections. Let's quickly highlight 5 key SDS sections that are most critical for worker safety. Section 2, Hazard Identification. This section alerts workers to the main dangers, physical or health, associated with the chemical. It includes pictograms, signal words like danger or warning, and hazard statements. Section 3, Composition Information on Ingredients, lists all hazardous ingredients and their concentrations. Knowing what's in the product helps in both exposure prevention and emergency response. Section 4, First Aid Measures, provides specific actions to take if someone is exposed, whether it's inhalation, skin contact, or ingestion. Section 8, Exposure Controls Personal Protection, outlines safe exposure limits and what PP is required like gloves, goggles, or respirators, based on job conditions. Section 10, Stability and Reactivity, tells us what conditions or materials to avoid, such as heat, sparks, or incompatible chemicals, to prevent dangerous reactions or explosions. Pause this slide to review all 16 sections. PPE is essential for protecting yourself when handling hazardous chemicals. Let's break down the main types. 1. Gloves. Protect your hands from corrosive or toxic substances. 2. Goggles and face shields. Guard your eyes and face against splashes. 3. Respirators. Prevent inhalation of harmful fumes or dust. 4. Protective suits. Shield your skin from spills and splashes. If a large spill happens, your first priority is safety. 1. Immediately leave an area of a large spill or release since you could be overcome by the effects of toxic chemicals. 2. Notify your supervisor or designated emergency contact. 3. Only trained personnel should respond by following site's emergency procedures. Remember, knowing the hazards is the first step to staying safe. Read the label, check the SDS, and speak up if you're unsure, because safety starts with communication. Thank you for your attention. Stay safe and work smart.